Hey everybody, it is 2015 Calculus AB question number 6. This one looks like it's going to be pretty quick. So in part A, equation of the tangent line. So immediately we write the equation of a line in point slope form. We need the point x1, y1, the point that the line goes through. Well, we know it goes through negative 1, 1. So now we know x1 is negative 1, y1 is 1. We just need the slope. What tells you the slope of the tangent line? Well, it's the derivative. So we find the derivative at that point. So we just plug that into the derivative. So we're going to get 1 over 3 times negative 1 squared minus, 3 times positive 1 squared. Minus negative 1, which is 1 over 3 plus 1, 1/4. So we just plug everything in, and we are done. Y minus 1 equals 1/4 x plus 1. That's it. You don't have to solve for y. That is the equation of a tangent line. It doesn't say which form, so we are good. That is part A. Let's do B. So you want the coordinates where you have a vertical tangent line. Well, a vertical tangent line has an undefined slope. To have an undefined slope, you have to divide by 0. So 3y squared minus x must equal 0. Well, you have one equation, but you have two variables, so you need a second equation with x and y. But you do have that. So you have two valid equations. Whoa, that was weird. So how do you solve those? Well, in your math career, you've learned 3 ways, I believe, to solve a system of equations. One is to graph it and see where they intersect. Well, that's really not an option here. That's too hard and too inaccurate. The second is elimination, where you get variables to cancel each other out. The third is substitution, and that's going to be the option we want. So on the first equation that we have over here, we're going to solve for x. So if you isolate x, you're going to get x equals 3y squared. Well, you're going to take that value of x and place into the other equation. So your other equation will only have x's in it. So you can get y cubed minus 3y squared times y equals 2. Y cubed minus 3y cubed equals 2. So subtract that, you can get negative 2y cubed equals 2. Divide both sides by negative 2. Y cubed equals negative 1. Y equals negative 1. So that's the y coordinate, where that happens. Now we have to solve for the x coordinate. So again, we have two equations to work with here. So we are going to take, actually that's not the two. Let's back up a little bit. Our first original two equations are these two. So let's plug this into this equation. and see what happens. Negative 1 cubed minus, oh, the y coordinate or x coordinate. We're going to solve for that. So why do we take the original equation? Because we have the y coordinate where the tangent line is vertical. So what gives us x coordinates? Well, we have to use our original equation because that's the one that finds the coordinates of the point. The equation here, that's the denominator of the derivative. That's what needs to be true in order to get a vertical tangent line. But to get the x and y coordinates, you deal with the original equation. Add 1 to both sides. So we have our answer 3, negative 1. And part C, we want to find the second derivative at negative 1, 1. So we have our first derivative. And we have to realize x is our variable, y is our function. So whenever we have an x, we treat it like a variable and just take the derivative. Whenever there's a y, that's got to be box. That's got to be treated as a function. So these are functions when we do the derivative. So take the second derivative. We have to do the quotient rule on the left. Quotient rule on the right. So it's low, d high, but the derivative of y is dy dx, minus high, d low. So the derivative of this is 3 box squared. So it's going to be 6 box to the first times the derivative of a box. But what's the derivative of y? Y is a function, so its derivative is dy dx over low squared. Now to do, I messed up. Let's back up a little bit here. Getting ahead of myself. So this was low d high minus high d low. The derivative of the bottom, I forgot to take the derivative of minus x. It's minus 1. That would have been ugly. Now we want to find this at a specific point. At xy equal negative 1, 1. So we're going to replace y's with 1, x's with negative 1. But what do we do with the dy dx? We could put all of this here and all of this here, but instead we're going to do some side work. We're going to say, hey, what's dy dx at xy equal negative 1, 1? Well, we already found that in the first part. Dy dx, right here, it's 1/4. We already found this to be 1/4. So in these pots, I'm just going to replace dy dx with 1/4 because that's the value at those points. So now we get 3 times 1 squared minus negative 1 times 1/4 minus, and y is 1, 6 times 1. Here it's 1/4. On the bottom, 3 times 1 squared minus negative 1 squared. That is the answer. You don't simplify. You shouldn't simplify. That'd be foolish. Leave it. We are good. That is the answer. We are finito, and that's it.